Welcome to the fascinating world of mechanics, where we explore how objects move and interact with forces. Mechanics is a branch of physics that deals with motion, forces, and energy. Whether it's a car speeding down the highway or a ball falling from a tree, mechanics helps us understand the rules that govern these actions. In this video, we'll break down the basics of motion and forces, and see how they shape the world around us. Let's begin our journey by understanding what mechanics really means and why it's so important in our daily lives. Motion is all around us, from the fluttering of leaves in the wind to the movement of planets in space. But what exactly is motion? In simple terms, motion is the change in position of an object over time. It can be fast or slow, straight or curved, and can happen in many different ways. Understanding motion allows us to predict how things will move and interact. Throughout this video, we'll look at different types of motion and see how they are described and measured in mechanics. There are several types of motion that objects can experience. The most common are linear motion, where an object moves in a straight line, and rotational motion, where it spins around an axis. There's also oscillatory motion, like a swinging pendulum, and random motion, such as the unpredictable path of dust particles in the air. Each type of motion has its own characteristics and rules, and understanding these helps us analyze everything from simple machines to complex systems. To describe motion, we use terms like distance, displacement, speed, velocity, and acceleration. Distance is how much ground an object covers, while displacement is the straight line change from start to finish. Speed tells us how fast something is moving, and velocity adds direction to that speed. Acceleration measures how quickly velocity changes. These concepts are the building blocks for understanding how and why things move the way they do. Let's take a closer look at distance and displacement. Imagine walking around a park. The total length you walk is the distance, but if you end up where you started, your displacement is zero. Distance is always positive and measures the path taken, while displacement considers only the starting and ending points, including direction. This distinction is crucial in mechanics, as it affects how we calculate other quantities like velocity. Speed and velocity are often used interchangeably, but they're not the same. Speed is a measure of how fast an object moves regardless of direction. Velocity, on the other hand, includes both speed and direction. For example, if a car travels 60 km per hour east, that's its velocity. If it just moves at 60 km per hour, that's its speed. Understanding this difference helps us analyze motion more accurately. Acceleration is the rate at which velocity changes over time. If you press the gas pedal in a car, you accelerate. If you hit the brakes, you decelerate, which is just negative acceleration. Acceleration can change an object's speed, direction, or both. It's a key concept in mechanics because it helps us understand how forces affect motion, whether it's a rocket launching or a ball rolling down a hill. Now let's talk about forces. A force is a push or pull that can change the motion of an object. Forces can start, stop, or change the direction of motion. They are everywhere, from the gravity that keeps us on the ground to the friction that slows down a sliding object. Understanding forces is essential for predicting and controlling motion in the real world. There are many types of forces that act on objects. The most common are gravitational force, frictional force, normal force, tension, and applied force. Each type of force has unique effects on motion. For example, gravity pulls objects toward the Earth, while friction resists motion between surfaces. By understanding these forces, we can better predict how objects will move and interact. Gravity is one of the most important forces in mechanics. It's the force that attracts objects toward each other, especially toward the center of the Earth. Gravity keeps us grounded, makes apples fall from trees, and governs the motion of planets and stars. Without gravity, life as we know it wouldn't exist. Understanding gravity helps us explain everything from falling objects to the orbits of celestial bodies. Friction is the force that opposes motion between two surfaces in contact. It can be helpful, like when it allows us to walk without slipping, or a hindrance, like when it slows down moving parts in machines. Friction generates heat and wears down surfaces over time. Engineers often work to reduce unwanted friction or increase it when necessary, depending on the application. Normal force is the support force exerted by a surface, perpendicular to the object resting on it. For example, when you stand on the ground pushes back up with a force equal to your weight. This normal force prevents you from sinking into the ground. It's an essential concept in mechanics, especially when analyzing objects at rest or in contact with surfaces. Tension is the force transmitted through a string, rope, or cable when it's pulled tight by forces acting from opposite ends. Applied force is any force that's applied to an object by a person or another object. Both tension and applied force play crucial roles in everyday mechanics, from lifting objects to operating machinery. Newton's first law, also known as the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion at constant velocity, unless acted upon by a net external force. This means that things don't change their state of motion unless something causes them to. It's why you need to push a stationary car to get it moving or apply brakes to stop a moving bike. Newton's second law explains how the acceleration of an object depends on the net force acting on it and its mass. The law is often written as F equals ma, where F is force, m is mass, and a is acceleration. This law helps us calculate how much force is needed to move or stop an object, and is fundamental in engineering and everyday life. Newton's third law states that for every action there is an equal and opposite reaction. This means that forces always come in pairs. If you push on a wall, the wall pushes back with an equal force. This law explains everything from how rockets launch to why we can walk by pushing against the ground. Forces can be balanced or unbalanced. When forces on an object are balanced, there's no change in motion. If they're unbalanced, the object will accelerate in the direction of the net force. For example, if you and a friend push a box from opposite sides with equal force, it won't move. but if one of you pushes harder, the box will move in that direction. Friction is everywhere in our daily lives. It allows us to walk, drive, and hold objects. Without friction, cars wouldn't stop and pencils wouldn't write on paper. However, too much friction can cause wear and tear, while too little can lead to slipping and accidents. Engineers design surfaces and materials to control friction for safety and efficiency. Gravity isn't just about falling objects. It's the force that keeps the moon orbiting the Earth and the planets orbiting the sun. Astronauts experience microgravity in space, which affects their bodies in unique ways. Understanding gravity helps us design satellites, predict tides, and even plan space missions. To reduce unwanted friction, we often use lubricants like oil or grease. Lubrication creates a thin layer between surfaces, allowing them to slide more easily. This is crucial in machines, engines, and even in our own bodies, like the joints in our knees. Proper lubrication extends the life of equipment and improves efficiency. Force diagrams or free body diagrams are visual tools used to show all the forces acting on an object. By drawing arrows to represent forces, we can analyze how they interact and predict the object's motion. These diagrams are essential in solving mechanics problems, from simple blocks on a table to complex engineering structures. Mass and weight are related but different concepts. Mass is the amount of matter in an object and doesn't change no matter where you are. Weight is the force of gravity acting on that mass. On the moon, your mass stays the same, but your weight is less because gravity is weaker. This distinction is important in mechanics and everyday life. Inertia is an object's resistance to changes in its state of motion. It's why you feel a jolt when a car suddenly stops or starts. The more massive an object, the greater its inertia. This concept is central to Newton's first law and helps explain many everyday experiences, from riding in vehicles to playing sports. Circular motion occurs when an object moves in a circle at a constant speed. Even though the speed is constant, the direction is always changing, which means the object is accelerating. This acceleration is called centripetal acceleration and is directed toward the center of the circle. Circular motion is seen in everything from spinning wheels to the orbits of planets. Centripetal force is the force that keeps an object moving in a circle. It acts toward the center of the circle, preventing the object from flying off in a straight line. This force can be provided by gravity, tension, friction, or other means, depending on the situation. Understanding centripetal force is key to analyzing circular motion. Projectile motion describes the curved path an object follows when it's thrown or launched into the air. The motion is influenced by gravity and the object's initial velocity. Examples include a basketball shot, a cannonball, or even a thrown frisbee. Understanding projectile motion helps us predict where objects will land and how far they'll travel. Free fall occurs when gravity is the only force acting on an object. In free fall, all objects accelerate at the same rate, regardless of their mass, as long as air resistance is negligible. This principle was famously demonstrated by Galileo and is a cornerstone of mechanics. Free fall helps us understand how gravity affects motion. Air resistance is a type of friction that acts against objects moving through the air. It slows down falling objects and affects the motion of everything from airplanes to raindrops. The faster an object moves, the greater the air resistance. Engineers design shapes to minimize air resistance and improve efficiency in vehicles and sports. Terminal velocity is the constant speed an object reaches when the force of gravity is balanced by air resistance. At this point, the object stops accelerating and falls at a steady rate. Skydivers experience terminal velocity after a few seconds of free fall, making it a crucial concept in both physics and extreme sports. Simple machines are devices that make work easier by changing the direction or magnitude of a force. The 6 classic simple machines are the lever, wheel and axle, pulley, inclined plane, wedge, and screw. These machines are the building blocks of more complex devices and are found everywhere, from playgrounds to construction sites. A lever is a simple machine that consists of a rigid bar that pivots around a fixed point called the fulcrum. Levers help us lift heavy objects with less effort. Examples include seesaws, crowbars, and scissors. By adjusting the position of the fulcrum, we can change the amount of force needed to move an object. Wheel and axle is another simple machine that makes it easier to move or lift objects. It consists of a larger wheel attached to a smaller axle, so when one turns, the other does too. This principle is used in everything from cars and bicycles to doorknobs and rolling pins, making movement smoother and more efficient. A pulley is a simple machine that uses a wheel and a rope to lift or move loads. By changing the direction of the force, pulleys make it easier to raise heavy objects. They're used in cranes, elevators, and even flagpoles. Multiple pulleys can be combined to further reduce the effort needed. An inclined plane is a flat surface set at an angle like a ramp. It allows us to move objects to a higher or lower place with less effort than lifting them straight up. Ramps, slides, and sloped roads are all examples of inclined planes in action. This simple machine is essential in construction and transportation. The wedge and screw are both simple machines that help us do work more easily. A wedge is a device that splits or cuts objects apart like an axe or a knife. A screw is an inclined plane wrapped around a cylinder used to hold things together or lift objects. Both are found in countless everyday tools and machines. Mechanical advantage is the factor by which a machine multiplies the force put into it. Simple machines allow us to use less force to move a load, but the distance over which we apply the force increases. Understanding mechanical advantage helps us design tools and machines that make tasks easier and more efficient. In physics, work is done when a force moves an object over a distance. The amount of work depends on the size of the force and how far the object moves in the direction of the force. Work is measured in joules and is a key concept in understanding how energy is transferred in mechanical systems. Energy is the ability to do work, and it comes in many forms. In mechanics, we often talk about kinetic energy, which is the energy of motion, and potential energy, which is stored energy due to position. When you lift a ball, you give it potential energy. When you drop it, that energy turns into kinetic energy as it falls. Law of conservation of energy states that energy cannot be created or destroyed, only transformed from one form to another. In mechanics, this means that the total energy in a system remains constant, even as it changes from potential to kinetic or vice versa. This principle is fundamental to understanding how machines and natural systems work. Power is the rate at which work is done or energy is transferred. It tells us how quickly a machine or person can do work. Power is measured in watts, and higher power means more work can be done in less time. Understanding power helps us compare the efficiency of different machines and engines. Momentum is the product of an object's mass and velocity. It's a measure of how hard it is to stop a moving object. In collisions, momentum is transferred between objects, but the total momentum of the system remains constant. This principle helps us analyze everything from car crashes to billiard games. Impulse is the change in momentum caused by a force acting over a period of time. It explains why airbags in cars help reduce injuries. They increase the time over which the force acts, reducing the impact. Understanding impulse helps us design safer vehicles and sports equipment. Collisions can be elastic or inelastic. In elastic collisions, both momentum and kinetic energy are conserved, like when two billiard balls bounce off each other. In inelastic collisions, some energy is lost as heat or deformation, like when cars crash and crumple. Understanding these types helps us predict outcomes in real-world situations. Mechanics isn't just theory, it's everywhere in our lives. From designing safer cars and efficient machines to understanding sports and building structures, the principles of motion and forces help us solve real problems. Engineers, architects, and scientists use mechanics every day to innovate and improve our world. We've covered the basics of mechanics, motion, and forces, exploring how objects move, the forces that act on them, and the machines that make our lives easier. Understanding these concepts gives us the tools to analyze, predict, and shape the world around us. Whether you're interested in science, engineering, or just curious about how things work, mechanics is a foundation for discovery and innovation. Thanks for joining this journey into the world of motion and forces.